Welcome back to the channel, guys. Today we are going to discuss the concept of inequalities in differential equations. Suppose we are given a differential equation in this format, like f dash x equal to c times fx. As there is a equality between left hand side and right hand side, we can directly solve this. F dash x by fx is equal to c, and so we can say if we integrate both sides with respect to x, we will get f of x is k times e to the power cx, where k is a constant. Now this is the simple case of differential equations where there is a strict equality between both sides. But what about the case when we have inequality between them? So let us say, for example, f dash x is greater than c times fx. Let us consider this case where c is a positive constant. Now in this case there is a fixed approach that we have to follow. So we take the right hand side term towards left. So f dash x minus c times fx is greater than 0. Now we multiply both sides by exponential term, which is in this case will be e to the power minus cx. So we multiply both sides by this, so we get this, and we can observe that this whole left hand side term is equal to the differentiation of e to the power minus cx times f of x with respect to x. So this derivative is positive, and this function's derivative is positive. That means this function is an increasing function. So if we assume a function g of x which is equal to e to the power minus cx times fx is an increasing function. Now let us assume that in the question we are given this fx is defined for a particular interval, let's say open interval a to b. So we have to compare values of f in this interval. So we can say that e to the power minus cx times fx, as this is an increasing function, this will be always greater than e to the power minus ca times f of a for all x greater than a. This we can tell by this relation. Now in the question we will be given something about this f of a to determine this value in the right hand side. So we can comment on the nature of f of x. So this is the approach that we have to follow in this type of functional inequalities. This question was asked in JEE Advanced 2013 in paper 1. You can try it before seeing the solution. In this question, we are given that f dash x is less than 2fx and f of half is equal to 1. And we are asked to find the range of half to 1 integration fx dx, where fx is positive for all x belonging to this interval. Now our given relation is something like that. So here we can write it as this. Now here if we multiply both sides by a positive number, e to the power minus 2x, so what will happen? Less than e to the power minus 2x into 0 will be 0, and then this left hand side will become the derivative of the function with respect to x, and the function inside will be e to the power minus 2x times fx, and this derivative is less than 0. You can see directly by this relation that if we differentiate this function inside this bracket, we are getting this. So we can say that e to the power minus 2x times fx. Let us denote this as phi x. Now this phi x is a decreasing function. Now this function is a decreasing function, so phi of x will be less than of phi of half, as x varies from half to 1. So we can say that in this interval phi of x should be always less than phi of half for x greater than half, as phi x is a strictly decreasing function. So this phi x we can write as e to the power minus 2x times f of x is less than phi of half will be e to the power minus 2 into half, so e to the power minus 1 times f of half, and f of half was given to us as 1, so this will become e to the power minus 1. So we can say that f of x is less than e to the power 2x minus 1 for all x greater than half. Now we know that if f and g are two functions such that both are positive in some interval, given interval a to b, then a to b integration fx dx and integration a to b gx dx, we can compare them. If in this given interval f is always less than g, then we can say that the integration of f and integration of g we can directly compare by this relation. So this integral fx dx from a to b will also be less than integral a to b gx dx if this holds. So this is the concept that we'll have to apply. Here f of x is less than e to the power 2x minus 1, and as the question says, f of x is positive and e to the power 2x minus 1 is also positive, so we can directly compare their integrations. From half to 1, integral f of x dx is less than half to 1 integral e to the power 2x minus 1 times dx. So we can evaluate this integral, like it will be e to the power 2x minus 1 divided by 2 and limits from half to 1. So this will be e minus 1 divided by 2. So integral half to 1 f of x times dx will be less than e minus 1 by 2. Now as fx is always positive function in this interval half to 1, so we can say that integral of fx will also be greater than 0. So this is the required answer. So option D will be our correct answer.